Today we want to discuss about acids, bases, and pH of solution. So I want to look at what an acid is, the properties of an acid, then examples of strong and weak acids, the same headings under bases. Then we shall end this video by looking at a calculation of pH of solutions. And if it is your first time to watch this channel, please go to where there is a subscribe button and subscribe. Like the video and then share to many others so that we can continue learning at medical sciences. So we want to see what an acid is. Acids or an acidic solution, we are going to define as that an acid is a solution that which dissociate to liberate hydrogen ions. To liberate hydrogen ions, which we call protons. So any solution that reacts or that dissociates to liberate hydrogen ions, or what we call protons, is what we call an acid. And in summary, we normally say an acid is a proton donor. It is a proton donor. That is what we call an acid. And after understanding that acids liberate hydrogen ions when they dissociate in solutions, or we are going to see that they are solutions which donate protons. And these acids are categorized into two. They are classified into two, whereby we have strong acids and weak acids. We have strong acids and weak, whereby strong acids, these ones ionize completely in solution. These ones ionize completely. Whereas weak acids, for them, they ionize partially in solution. These ones ionize partially in solutions. And examples of strong acids, examples include hydrochloric acid, sulfuric acid, and nitric acid. So sulfuric acid, nitric acid, and hydrochloric acid, these are examples of strong acids that in solution, if I have, for example, hydrochloric acid as a strong solution, as a strong acid, it dissociates completely. That is by using a full arrow to liberate hydrogen ions, that is proton, plus chloride ions. So that's why we are saying strong acids, they dissociate or ionize completely in solutions to liberate hydrogen ions. Whereas weak acids, we're going to see weak acids like acetic acid, or you can call it ethanoic acid. There is glacioacetic acid. There is weak carbonic acid. So these are examples of weak acids, even not forgetting lactic acid. So these are weak acids, and we are saying for them they ionize partially in solutions. For example, if we have acetic acid or ethanoic acid, it dissociates partially to give ethanoate ions plus liberating hydrogen ion. Or if I have this weak carbonic acid, It dissociates also partially to give hydrogen ions plus bicarbonate ions. So they partially dissociate. If we are to balance here, we put 2. And after looking at examples of strong acids and weak acids, now we need to know about the properties. Properties of acids. And among the properties of acids, we are going to see that acids turn moist red litmus paper, they turn moist blue litmus paper red. Blue litmus paper red, that is one of the property. And another property of acids is that they are corrosive. They are corrosive, so if you touch them with bare hands, they can easily burn you. And another thing, they have sour taste. Their taste is sour. And these acids, they liberate carbon dioxide when reacted with the carbonates. When acids react with the carbonates, they liberate carbon dioxide gas. And lastly is that these acids, they produce salt and water only. Salt and water when reacted with the base, when they react with the bases. So acids react with bases to liberate salt and water only. So these are some of the properties of acids, whereby they turn blue litmus paper red, they are sour in taste, corrosive, meaning you cannot touch them with your bare hands, and when reacted with the carbonates, they liberate carbon dioxide only, and when they react with the bases, they produce only salt and water. So these are the properties of us. So in case they ask you to outline any 4 properties, you should be able in position. Or if they ask you that which of the following are examples of weak acids, or the following are weak acids except, so you are required to know examples of weak acids and examples of strong acids, not forgetting that acids are proton donors. And these acids at the pH, they have acidic pH. Their pH, as we are going to see the other side, their pH is always less than 7. Their pH is always less than 7. So let us look at number 2, which are bases. And these bases, for them, they dissociate. These ones, or in summary, we can say bases are proton acceptors. These accept the protons in solution, and that's why we call them proton acceptors. For them, they accept the hydrogen or protons. So those are the bases. So in solutions, bases act by accepting protons. And these bases, they can be categorized into 2, whereby bases can either be strong, they can either be strong bases, or they can be weak bases. And strong bases, for them, they dissociate completely in solution. These ones dissociate completely in solution. And example of strong bases include sodium hydroxide, potassium hydroxide. These are the peculiar examples of strong bases: sodium hydroxide and potassium hydroxide. So these are the peculiar examples of bases. then even sodium oxide is a base. Then other examples. So what we are saying that these strong bases dissociate completely is an example. If I have sodium in solution, it dissociates completely to give hydrogen ions and hydroxyl ions, and it is these hydroxyl ions that accepts the proton in solution to form water. So that is the example of a strong base commonly used. Then weak bases, for them, they dissociate partially in solutions, and they include, weak bases include sodium hydrogen carbonate is one of the example of the weak base. I can even ask another base is ethanoate, sodium ethanoate. Sodium ethanoate is also an example of a weak base. So these are examples. So strong bases dissociate completely or ionize completely, whereas weak bases, for them, they ionize partially. And of course, when this one ionizes, like for example, sodium bicarbonate, sodium hydrogen carbonate, it dissociates partially to liberate sodium ions plus bicarbonate. And this bicarbonate is the one that is going to act as a proton acceptor. That is what we can look at bases. And properties of bases include that these bases, when in solution, they turn red, moist red litmus paper. They turn moist red litmus paper blue, meaning they are alkaline in nature. They have a soapy feel. When you touch them, you feel like they are soap. So they have a soapy feel on touching. That is another property of bases. And another property of bases, after knowing that they are alkaline in nature and they turn litmus paper blue and they have a soapy feel, we have seen they can also react with acid to produce salt and water. They react with acids to liberate salt and water only. Salt and water only. So these are some of the properties of bases. Turn red litmus paper blue, moist red litmus paper blue. They have a soapy feel, and they can also react with acids to form salt and water only. So after looking at acids, bases, and their classifications, including examples, I've told you in exams they can easily ask you the following are strong bases except, or the following are weak bases except. So you need to know different bases. Is it a weak base? Is it a strong base? And even the properties. So after exhausting this part, we are now going to end by looking at the pH of solutions. We want to look at the pH of solutions. pH in full is called potential hydrogen, and this potential hydrogen is defined as alkalinity. pH is the alkalinity, the degree of alkalinity and acidity of solution. That is what we can define as pH. Or pH can be defined as, in the form of a formula whereby we say pH is equal to negative logarithm base 10 concentration of hydrogen ion. That is also the definition whereby pH is negative value to base 10 negative value logarithm base 10 concentration of hydrogen, and that is the definition of pH. Negative value logarithm base 10 of concentration of hydrogen ions. And this pH, which we are saying it is the degree of alkalinity or acidity of the condition on a pH scale. On a pH scale, we see that pH begins from 0 up to 14, whereby in the middle there is 7.0, which is neutral. So we are going to see that here it is neutral, then this is alkaline, then this is acidic. So below 7, pH below 7 is acidic, pH less than 7.0 is acidic, then 7 is neutral, then pH greater than 7 is alkaline. And at a neutral pH, we are going to tell you that at a neutral pH, the concentration of hydrogen ions should be the same as the concentration of hydroxyl ions in the solution. Then in acidic, it means here the concentration of hydrogen ions is very high, and here we find concentration of hydroxyl ions. This bracket means concentration. That's what it means. So this is the pH scale which determines acidity and alkalinity of compounds. And after having the first formula pH equaling to negative log base 10 concentration of hydrogen ions, if I can also calculate pOH, whereby pOH is equal to negative log base 10 concentration of hydroxyl ions. This one is also pOH. I can get it by using that formula. And also, if I have pH and you have pOH, and even we have seen pH is equal to negative log base 10 to concentration of hydrogen ions, we can easily say that pH plus pOH is equal to 14. This one can be another formula for calculating pH, that if I have pH and I have pOH, pH plus pOH should be give me a total of 14 degrees. So these are the formulas we are going to be employing in the calculation of pH. pOH is equal to negative log base 10 concentration of hydrogen ion. Even pH is equal to negative log base 10 concentration of hydrogen ions. And pH plus pOH is equal to 14. So here we can look at example of calculating. You can ask yourself that how do we measure pH of solutions? The instruments used, we are going to see we use pHmeter is the most accurate. Then in urinalysis, we normally use heuristic to determine pH. We can also, but the most commonly used is pHmeter is used. So that is an instrument that we use. So after seeing this, we can see examples. In case I tell you that I have a solution containing 0.001 molar hydrochloric acid, and I ask you to calculate the pH of the solution. This one we can easily calculate it by saying that pH is equal to negative log base 10 concentration of hydrogen ions, whereby it is negative log base 10 concentration, which is 0.001 molar. And this one we can easily convert it to become log base 10. Then this one to make it a whole number, if I'm going on the right side, the power becomes negative. So it is going to be 1.0 times 10. I have moved the 1, 2, 3 to power negative 3. So this is the exponential form of this. Or if you have a calculator, you can put it directly. Then here we apply rules of logarithms, whereby it is going to become negative log base 10. And when we are multiplying and the bases are the same, what we do, we add. So it is going to be 1 plus negative log base 10, 10 negative 3. And this one is going to be lead me to negative log 10 of 1 plus negative 3 log 10 of 10. And at the long run, if I don't go in the details, at the long run, even if I stop here without applying rules of logarithms, I'm going to tell you that this one is going to give me, this negative shall come this side, it joins with the negative. It becomes negative 3 log 10, 10. And I will end up having pH equaling to 3. Because log 10, 10, that is 1. 3 times 1, which gives me 3. So this is what we can calculate pH. Another way, an examiner can tell you that given that the concentration of neutral water is 10 times, it is 1 times 10 to power negative 7 mole per liter, and they tell you to calculate the pH. They tell you to calculate the pH, and remembering that pH is equal to negative log base 10, pH will be equaling to negative log base 10 concentration of hydrogen ions in water, which is this. Because why do we use hydrogen ions? This is a strong acid, so on dissociation, the hydrogen ions still will be 0.01 mole. Even in water, the same thing, which is going to be 1 times 10 power negative 7. And this one still shall give us pH as 7.0. So pH of neutral water is 7. Then lastly, they can tell you to calculate pH, that given that pOH is equal to 9.0, pOH of the solution is equal to 9.0, then they ask you to calculate the pH. And how do you calculate this pH? From the formula, pH plus pOH is equal to 14, pH plus pOH, which is 9. We have been given that pOH is 9, is equal to 14, and pH is equal to 14. This one I take this side, it becomes subtraction, minus 9, and 14 minus 9, that is 5. So pH of the solution becomes 5. So this is what we can cover under this video, whereby we have looked at acids, bases, and we have gone ahead to talk about pH of solutions, which are determined majorly by using pH meter. And this pH meter, whereby pH is the measure of the degree of acidity or alkalinity of the solutions. And we have seen different methods used whereby We can use pOH is equal to negative log 10, concentration of hydroxyl ions, or pH is equal to negative log base 10, concentration of hydrogen ions. And we have seen even that if we add pH plus pOH, we should get a total of 14. And we have seen examples how we can calculate pH of solutions. Thank you so much for learning at Medical Sciences. Hope you gain a lot from us. Thank you so much.